All right, welcome everybody. We have Andre here for testing with Hardhat. Andre, how you doing?
Doing fine, GM everyone. Yeah, I'm so happy to be here to host this workshop for you.
All right, cool. With that, Andre, take it away. All you.
Thanks, man. Yeah, so welcome everybody to another Chainlink Spring 2022 workshop. I hope you're enjoying Hackathon so far. We're started yesterday and the day before with some basics, with Solidity development and Remix and Truffle, Hardhat, Brownie, Foundry, all of these frameworks, tools. And now we're going to level up our Solidity a bit more. And we are going to start with the testing. So today's topic is testing with Hardhat. Let's quickly do some GMs in the chat so I can see that you can hear me, see me, and then we can slowly start with today's topic. All right. Cool. So I think we can start. My name is Andrei Rakic. I'm one of the developer advocates for Chainlink Protocol at Chainlink Labs. You can see here listed my Twitter handle, my email, so you can reach me out anytime to chat about testing with Hardhat or anything Chainlink related. I'll be more than happy to answer you. Probably on Twitter will be better because I'm more active on Twitter, so we can either chat on some threads or in DMs. Or in DM. I'm fine with either of that. Let's start with quickly with the agenda. So in next approximately 15 minutes, we're going to cover some basics about testing smart contracts. I called that here testing smart contracts 101. Then I'm going to show you some tools for testing with Hardhat, like specific with this framework, and then like most of our time will be just demo. We will be demoing unit testing in Hardhat using TypeScript, and I'll talk about TypeScript a bit later. So first, let's start with some basics. So why we need testing in first place? So the reason is basically programming smart contracts is essentially more like programming hardware than programming software, if you think about it. So once you deploy your smart contract to any general purpose blockchain, uh, because of the nature of the blockchain technology itself, that code is immutable. This means that you cannot change your smart contract just one simple line. You cannot modify it. You cannot patch 0 days vulnerabilities and so on and so forth. So it essentially is it more like programming hardware? Imagine that you are like creating some cell phone, for example, and once the buyers buy your specific piece of cell phone, uh, imagine there's no service, and you can't patch that phone. You can like there's no updates or whatever, and that's basically the situation here on the in the smart contract development, right? So it's really important that your Solidity files or Viper files or whatever coding language you're going to use for it is a really good test, stress test, and also that it went to audit phase. So one thing also to mention is that audited code doesn't necessarily means that it is secured code, but still it is a good practice to pay for audits, right? So to step back to the testing one more time. So your flow will be to build something, then testing, test that thing, and then repeat and repeat and repeat that flow until you feel comfortable that you're like finished with the development of smart contracts. During that phase, your best friend will be TDD, or test-driven development, which is a simple technique where you first write your tests for each use case. You're going to write your unit test or unit tests or integration tests or staging tests or end-to-end tests or property-based tests. We will see what these phrases means. But basically, you write your set of tests and then you deploy functionality inside your smart contract. So at the beginning, your tests will be failed tests, right? All of them will be failing because there's no implementation in your smart contract. And then your goal is to write your implementation until those tests like became green test, and all of them that is passed, right? So there's different kinds of tests. So when you're testing your smart contracts, it's important that you choose your proper testing strategy wisely. So there's several testing strategies over there, but this is the most common and probably the most used. So there's like four main pieces of tests. So the first one and the basic ones are unit tests. What that means? So unit tests are basically independent tests of each of them are independently of each symbol of like the tiniest functionality inside your smart contracts. So all of these tests are deployed to a local blockchain. In our case, that will be local Hardhat node. And then we are going to deploy only one contract, and we are going to write unit tests just for that one contract. And the rest of the contracts we are going to mock. So mocking is a really common practice where you basically have like the predefined values for your other contracts, or maybe you're integrating some other protocol, and basically you're going to write your mocks in a way that it will return always the same value. We can be like true, false, or some numeric value, or some string, whatever. But you're basically mocking the behavior of your environment to unit test your simple functionality, and that's like really common thing. You basically say, hey, I want you, for example, this ERC20 token to always this transfer function to return true, because I'm not testing that functionality of the ERC20 or ERC20 token, for example. Now I'm testing my functionality inside my unit test, which basically calls transfer function on ERC20 token, for example. Then the second type are integration tests. So integration tests are also done on a local blockchain, but now we have multiple deploy contracts, and there's no mocks. So this is like the difference between unit test and integrational test. There's no mocks. And imagine now that you're creating some contract for governance function, for example, and you're casting votes by burning some ERC20 token, some governance token, right? So now inside the unit test, for example, you're going to test only that functionality for casting votes, and inside unit test for your governance token, you'll test the burning functionality. But now inside the integrational test, you'll basically test the whole flow, like so casting votes, burning tokens, etc., and like the whole user flow for voting will be tested inside the integration tests. The third type are so-called end-to-end tests. So the difference between integration tests and end-to-end tests is that integration tests are performed in a local blockchain, which only has like your deployed smart contracts, its state, and that's it. But with the end-to-end tests, we can have so-called mainnet fork. That means that we are going to test in a specific block, we are basically going to copy the whole state of the mainnet in a specific block, and we are going to perform tests on that environment. Why is that important? Because inside the local blockchain, there's no other protocols. There's no previous states previous state on the mainnet, and you want to be sure that you're testing against mainnet state. So this is like why end-to-end tests are so important, because you're basically going to integrate with your smart contract, maybe on locally deployed or some testnet, whatever. So that's like the third phase. And the final are property-based tests, or so-called fuzz tests. So fuzzing is like a common word for this property-based test, not the happiest naming, but basically what you want to do is when you're writing your tests, you're going to test some edge cases, right? So you're going to test, for example, if you, again, come back to this governance example, you're testing if your vote is 0, for example, this is an edge case, then like if you casting with 1 vote, if you cast with amount of 2, amount of 10, and that's it. Like you'll have like 3 or 4 different tests, and that's it. With property-based test or fuzzing, basically the fuzzer will generate all of these random inputs for your test and for your smart contract. And goal of the fuzz test is basically to break your implementation of the smart contract with basically stress testing with different inputs, different outputs, variables, switching the timestamps, whatever. Basically, it's going to stress test your smart contract, and the goal of your functions is to behave properly, right? So basically, you are going to write your fuzz tests or property-based tests in Solidity, and you basically want to say, I want this state variable, for example, to be always greater than 0 or 0 or whatever the condition is. And the goal is for fuzz test basically to break your sequence. If it fails, that's good for you, because this is the successful property-based test. So another and final thing, which is really important, are fixtures. So fixtures are testing scenarios that are executed once and then remembered by making a snapshots of the blockchain. So fixtures are basically a way to speed up your tests, because usually, like if you take a look on some like common projects, or maybe if you do that initial creation of Hardhat project. So if you type like npx Hardhat in it, you'll have like that famous greeter contract and like simple deployment scripts and like simple tests. If you take a look at that test, you will see that the deployment to a local blockchain of that greeter contract will happen inside the before each hook. So before each hook is basically a hook. It contains a simple piece of code which is going to be executed before each of the tests. And as I said, we are tending to make our unit tests independent of each other. And if you have like 15 different unit tests, you will have 15 deployment to a local blockchain. With fixtures, our goal is to deploy only once, and then to create so-called fixture loader. I will show you how to do that. And then inside the before each hook or hooks, just to load the deployment instance, and then to basically unit test that instance, which will speed up our tests significantly. So now let's take a look some common tools when we are testing stuff with Hardhat. And the first and the most important are Waffle, which is a library for writing and testing smart contracts. Then we have Mocha. Mocha is basically a JavaScript/TypeScript testing framework for your browser or Node.js. And finally, we have Chai. So Chai is an assertion library. That basically means that Chai will provide some function for us, like accept something to equal something, or assert some condition. And we need Chai in order to finish our tests properly. And before I cover this code coverage, I must say that we are going to test now with to write our smart contract, to write our tests for our smart contracts in TypeScript and not JavaScript, because TypeScript is more type-safe language than JavaScript and has some built-in functionalities. We're going to use TypeChain, and that's my recommendation also for you to write your tests in TypeScript when you're working with Hardhat, because essentially TypeScript is a better language, or not better, but safer language than JavaScript. If you go to Hardhat Starter Kit on Smart Contract Kit GitHub organization and git checkout to TypeScript branch, you will see that we now implemented also our Hardhat Kit purely in TypeScript. So you can take a look also and see how we properly test our smart contracts there using TypeScript. And also you'll notice how we wrote the property-based test inside the fuzzing folder. So the next thing is this code coverage. So code coverage is a simple tool, and it's not a tool, but there's like a tool to measure this. But code coverage essentially is a measure in percent of the degree to which smart contract source code is executed when particular test suite is run. So basically, when you run your coverage, you will see the percentage of how many lines of code you tested. So ideally is to have like 100% percentage of cost coverage, to touch all of these branches and everything. But my recommendation is that if you finish your smart contract tests and you have like 90+%, maybe 97%, 94, whatever, that this is essentially enough. Because in some case, maybe you'll have 99% and you want to reach out to finally 100%, and maybe you'll change something in your smart contract logic, and maybe you'll adjust some tests to reach that famous 100% coverage, and that can maybe result in some unexpected side effect or bug. So 90+% is okay, ideal is 100%, but don't uh, chase that 100% at any case, right? And that's basically it. We are now going to demo the testing with Hardhat. So if you go here, so what I basically wanted to show you is this Hardhat starter kit. So if you switch to TypeScript branch, you'll have the ability to look all of our tests written in TypeScript. So for our today demo, we are going to use this repo, Andrei Rakic /Hardhat -testing. So make sure to clone this or use this template, because we are going to use this template for writing tests today. So on the main branch, you will have the simple starter repo. On this Chainlink Spring 2020 hackathon, you will have like the final repo, so you can follow along. But we are going to start with this main. So Hardhat -testing, it is a repo for us. Make sure to clone it or use this template, and we can start from here. Okay. I already cloned my repo here, so I'm going to quickly take a tour inside this repo. Okay, so I took a simple smart contract from DeFi minimal repo, and it's a landing.sol. So this is the whole contract we are going to test now. So I hope you can see this, right? Maybe I can zoom it a little bit. Okay, so we have this landing smart contract. So what we are going to do, there's only one function, this deposit function, and we are going to write unit tests for this deposit function. Okay, so this deposit function takes address of token as an input parameter, and also amount of tokens you're willing to deposit. And it has some modifier, which is this, more than 0. So this amount needs to be greater than 0. So we are going to test that. It's going to emit this deposit event. So we are going to test emitting events properly with proper parameters. There's also this mapping, which is like a storage variable. So we have like mapping inside the mapping. So there's like an account, which is a key for another mapping, and that another mapping has token address as a key, and then exact amount. So we are going to test that the state is updated properly. Then we have this transfer form function for ERC20 token, and we are going to mock this token. So this is how I'm going to explain you how to mock things in Hardhat. And so it can be this success variable can be either true or false. We're going to test when it's true, and also we're going to mock to test when it's false. And then, like if it's false, we need to revert with this custom error, which is transfer failed error, and then we are going to test that as well. So if you go to the test folder, try first to navigate to shared folder. So inside the shared folder, you will see types.ts. So this is the first file. Basically, our idea is, because we are writing everything inside the TypeScript, to declare some TypeScript types for our tests. So basically, we have this context interface with load fixture function. So as I said, we are going to load our fixtures inside the before each hook. We have signers, so deployer, Alice, and Bobs are our signers. We have mocks, and the only mock contract will be in this mock USDC token, and then landing. And landing is basically our smart contract. So landing type comes from the type chain when you like compile your smart contract, right? So inside the mocks, you will have the ability to see how you can deploy mock USDC tokens. So basically, you have this mock contract. I have ABI here. This is a common ERC20 ABI, and then we are mocking basically all of these functionalities. So Decimus will be 6, name will be USD coin, symbol USDC, and transfer form we basically want all the time this function to return true, because we are not testing now a simple transfer of our token. We are basically testing our lending, and inside the deposit function you see that transfer form. So basically we want to always return true, because we will test that whole flow inside the integrational test, not unit tests. Okay, and finally we have fixtures. So inside the fixtures.ts file, you will see basically how I created fixture for this test. So we have this type again. We are basically returning lending contract and this mock token. And inside this unit lending fixtures, we basically deployed our lending token to our local blockchain, same piece of code, which from, for example, before each hook on general Hardhat template example, and then we'll just call this deploy mock USD contract function from this mocks.ts folder, and we return these two objects, and that's it. Inside the unit folder, we have this index.ts, and inside this index.ts, we have this describe station, which is unit tests. We loaded all of these signers, and then we loaded these fixtures. So we are creating great fixture loaders with these wallets. And now inside this, before each hook, we're just loading our fixture. So we have this lending token, a lending contract, and this mock token, and then we assign these these values, and that's it. We can now call this function. So should deposit function comes from lending, then lending should deposit.spec file. So if I go to lending should deposit.spec.ts and should deposit function, and now we have context and basically a test. You should start here, and we'll basically start with writing unit tests here. So as I said, we are going to write tests for this lending.sol. So maybe I can split right. Yeah. So basically, to see the implementation of the smart contract itself, and then we can write one test at a time. Okay. So let's quickly delete this, or maybe we can just try to see if this works. Yarn tests. Okay, you should start here. Perfect. We have our terminal. We can start from here. Okay, so let's first see the implementation. So if we take a look at this deposit function, we have this more than zero modifier. So we first need to check that this amount is greater than zero. So we can write something like it should, for example, revert if the token amount is not greater than zero. Okay, so this is our message. And let's start. So we first need amount. Okay, so amount will be 0, but I highly recommend you to use constants from ethers package. So if you type something like ethers dot, I need to import this ethers. Sorry, yeah, ethers dot constants dot. You can see like you have address 0, ether symbol, whatever, 1, 2, -1, maximum uint, all of these simple constants for edge cases. I'll use this 0. Okay. And then what we basically want, so we are going to write something like await expect. So expect is come from Chai assert library, and we are expecting that deposit will be reverted with this needs more than 0 custom error. So how to do this? So because we already load our deployed contract from fixtures, we can write something like this. This dot lending dot deposit. Deposit is the name of the function, and then the first thing is token. So this dot mocks dot mock USDC dot address, And another parameter is amount. And we also want, so if I, before calling a function, do this connect, and then this dot signers dot alice, this means that basically Alice is calling this smart contract, this function of a smart contract inside the test. And this is important because you can type something like this dot DAO or this dot only owner, and then you can test, like if you call this function with this dot DAO, it succeeds, but if you call with this dot Alice, for example, it fails because Alice is not an owner or something like that. So we want to this deposit function to be reverted, just to be reverted. Okay, so we want this function to fail. Okay, let's try to see if this is going to revert in the first place. So yarn test, and boom, it succeeds. So this function reverted, this test reverted, right? To make this more clear, we can add something like reverted with, and then we can provide the name of the custom error, and it is needs more than 0. So we want not this function just to revert, but we want to be sure that it's going to revert with the proper save, with the proper, oh sorry, I broke this, with the proper error message, right? So let's move this to the right again, sorry. Let's open our integrated terminal one more time, and let's type yarn test. And boom, our first test succeeds. Okay, cool. I can move this down. Let's write another one, okay? So give me a sec to close this. Okay, because it's bigger. So it, again, we should have some string as a name, and then async function, open parentheses, sorry, curly brackets. We are good. So we tested this more than 0. We can now test that this function should emit proper events. So we have like emit deposit. So it should emit proper event, right? Event. Okay, so how to do this? So again, we need amount. So const amount is equal ethers, sorry, ethers constants 0, 0. And because it is an uint 256, the type of this amount is a big number. So you can specifically type it like this. And then we are going to write something like this. So await, again, we are expecting this dot landing, now connect with this dot signers dot alice, deposit function. Okay, here it is. This mocks mock USDC address and amount. Now not to revert, but to emit a proper event. So emit has two parameters. So first one is contract. So I need to type this dot landing, and this is a contract instance. And then the name of the event itself, it's deposit. And you can additionally add some arguments. So to emit this event with this set of variables, but let's quickly test first this. So if I again run yarn test, now we have two tests, right? Okay, with custom error 0. Okay, what I did is basically I screw up this amount, so it needs to be greater than 0, so we can type 1. Okay, let's run our test one more time. Yarn test. Now we have two functions, two tests pass, right, passed. So as I said, you can add something like emit with args, and now we have three arguments. So message.sender is Alice in this case, because we are calling this function from Alice. So this signers alice.address. Second is token, so this.mocks.mockUSDC.address. And third one is in amount tab. Let's save. Let's run test one more time. Yeah, you can see it here, and it passed, right? So we have two successfully passed tests. Really good, very good. Okay, third, we have this storage variable, right? So we want this storage mapping to be updated properly. So for the first two tests, we used expect because we expected this error to be raised up or to revert function with this error. Then we expected this event to be emitted. Sorry, and we are now going to expect this storage mapping to be updated properly. But for this, we are going to use assert. So assert is another really awesome function from Chai assertion library, which is going to say something like assert that this value is equal or not equal to this value and raise this error message. Okay, let's start with our third test. So once again, we now need async function or brackets, curly brackets. We need some meaningful name for this test. So it can be something like it should update storage variable properly, right? Okay, so for this test, we first need to have like previous amount. So if I do something like cost previous account to token deposits, I can call my method, my variable, sorry, in TypeScript like this. And if I scroll a bit up, you can see that this mapping is public, which means that it's going to automatically create a getter for us, Solidity getter, to grab this value, which is really good. I will just copy this. Deposits equals await this lending dot as account tokens. Here's our getter, and just we need to call it properly. So first we need an account. So this will be this dot signers dot alice dot address. Okay, and then for a mapping we will have another key which is token. So this dot mocks dot mock USDC dot address. Okay, and I'm going to save this, and I can either even console log this value. Okay, so console log previous account token deposits. Let's run our test one more time. Yarn test. Okay, so you can see that now all of these 3 tests are executed, and imagine that you have like 15 tests or something. This kind of get annoying. So if I add here it.only, it is going to basically execute only this test and not this previous one. So once again, if I do yarn test, now we have only this should update storage variable properly test execution. And we have our console log. Basically, currently the mapping value is 0 because we actually haven't modified it yet inside this it bracket, because as I said, we tend to make each of these unit tests independent. So we're always going to start with a 0, right? So this is our previous balance. So we want to now just call our deposit function and see what's going to happen, right? So await this dot lending connect. So we're going to call it again from Alice, signers dot Alice deposit. First is token, so this dot mocks dot mock USDC dot address, and the second one is an amount which we don't have. So I'll quickly add amount here. Const amount big number equals this dot sorry, not this, ethers dot constants dot one, number 1. Okay, and now let's quickly run our test once again to see that this is not broken and it's not perfect. And now after the execution of this deposit function, we should get the new or the current account to token deposits value from our mapping. So once again, const current let's see, account to token deposits equals again we can just call this getter function once again. Save it, and again, console log current account token deposits, right? Yarn test. So we can see that now the value is 1, and this is the unit 256 value, okay? We can either not call this 1 because this is basically one way. We can call something like parse ether and then 1, and now it's going to be in ether or with 18 decimals. So if I run again yarn test, now it's 1 ether or 1 and 18 zeros in ways, which is more common, right? Because this is again UN256 value on the blockchain of the smart contract and the Solidity code itself. So let's now just add type. So this will also be big numbers, right? Big numbers. And then what we want here is to basically call assert function. So assert, I'm going to tab to see assert, assert try. Yeah, that's much better. So assert that we have some expression, some conditional value, and we have some error message. Okay, so we want basically to current account to token deposits to equal, and by type this three signs basically means that is going to compare your type as well, to equal previous account to token deposits plus amount. Okay, like addition, because and now we have this error, red error, and it basically happened because we have TypeScript. With JavaScript we will basically we will not have this how to say it, VS Code warnings or errors, and then we will just hit to our or encounter our error inside the terminal itself. So let's quickly take a look what this means. So basically said operator plus cannot be applied to types big numbers. So because this is a big number, it has like built-in function for addition, and it is add. So I need to write it like this. So we basically want, I can move this a bit to the side. We want, or maybe I can just save it, yeah, to a current account to token deposits equal previous plus amount. And some error message can be something like maybe new value should equal previous plus amount, something like that. Okay. And then let's run our test one more time, yarn test. And it failed. And this is like hard error to debug because we are not sure what we wrote bad here. We expected this to be true. We also console logged these values, and saw that it is like it should be true because we saw the values, but we have the error. So let's quickly debug this. So we have assertion error, new value should equal previous plus amount. So the error executed here. So either the condition is not okay, or we haven't properly used this assert function. So because we are sure, because of the console logs, that this statement is true, if you basically Google this error, you will see that assert function doesn't handle big numbers. And our type is big number because it is uint256 in Solidity file. So what we're going to do here is basically we are going to cast our big numbers to regular integers and then to execute this function one more time. So to do this, we just need to add this to big int, and here we'll have to big int. Give me a sec. Yeah, I think I can add it after this addition. Let me see. To big int and save it, and hopefully we are going to solve this yarn test. And boom, it works. So we have now a successful test. It's a good practice to delete all of these console logs because like we don't need it really. And also we are going to delete this dot only statement, because right now we have 3 final tests, so we want basically to run them one more time to see that everything is working okay, and it is. So right now our deposit function should revert if the token amount is not greater than 0 because of this modifier, and this is tested. Should emit proper event with proper parameters, this is tested as well, um, and should update this storage variable properly, this is tested as well. And this is all because this success is always true. So why it is? Because if you come back to mocks.ts, we basically, let's quickly close this. We said that for transfer from function, make it always return true, and that's it. We are now want to mock this token to return false. So right now, for the purpose of our unit test, we want to test that this custom error actually executed. So what we are going to do here is that we are going to mock our transfer from function from our mock USDC token to return false instead of true. And our success Boolean variable will be false and not true. Okay, so how to do this? Again, async function, parentheses, curly brackets, and let's type something like should revert. Yeah, should revert. Should revert with transfer failed error. We can call it like this. Okay. And now the first thing is that we are going to try to mock this stuff. So I copy paste this from mock.ts. The syntax is a bit different. So we are going to do something like await this .mocks.mock USDC, and then type mock transfer from returns false. We now want our function to return our transfer from mock function to return false in order to test this condition, right? And before actually, I can comment this a bit. Let's run quickly yarn coverage to see at which percentage we are now. So as I said, I mentioned at the beginning, we have like coverage tool, which is going to basically, it is a measure of percentage of how much of the smart contracts is properly tested with tests. So if I type yarn coverage, landing.sol compilation, give us a sec. We can see that currently 75% of our smart contract is covered with tests. And why is that? Because we tested this branch, which is like a quarter of a function of a whole smart contract, actually, because we have only one function. Then we tested these events, which is like 50%, this storage variable 75%, and this last 25% of is not tested because we haven't tested this branch still. So because I run this coverage function, you can see reports written to .coverage or and coverage.json, and it's here automatically generated for you, so you can see like your basically your report, right? So this is coverage, and we have this coverage.json, and let me quickly save this or format with JSON. Yeah, and if I close this, let's quickly analyze this coverage.json. We can see that all of these lines are tested, path, and we have here 0. So this is B2. If I go to 2, branch map, yeah, B, so branch map B2 on line 44. Yeah, this is the line 44. We have like, so you can see 0 tests for branch number 2. So this is functions and function map. This is F, statement map S, and then branch map 1, 2. So B2, this is not tested. And if you go to line 44, it tells us you haven't tested this branch on line 44. And that's true. And let's now write a test for this use case. So again, let's quickly move this to the right. We are mocking our USDC mock ERC20 token to returns now false from transfer from function. And the pretty much the flow is the same. So we have amount, which is going to be a big number, parse ether 1. We basically want to await expect this.landing called by Alice, this.signers.alice deposit is the name of the function. Token is this, mock USDC address, amount is this, to be reverted, just reverted, to see if this is going to revert. Okay, give me a sec, yarn test. We can write our unit tests now, and yeah, it actually reverted, but we want to test that it reverted with the proper custom error. So if you remember our first test, it's going to be reverted with, and then the reason is transfer failed. So I can just copy this, paste it here, save it one more time, yarn test, and boom, now we have like a fully working test. We can now once again clear, let's put this over here, run yarn coverage to see that everything is working fine. And it is. So coverage executed our test suites one more time. We have 100% of code coverage for our simple smart contract with only one deposit function. And this is how we wrote our first set of unit tests. Where to go from here? So now, after you know how to execute unit tests, how to write and execute unit tests, you can basically start to write your functional tests. So functional tests will be inside the functional or function whatever folder, and then you want to follow this this structure. It's clear and readable. But inside your, for example, landing should deposit.spec.ts file inside the functional folder, you're not going to use mocks. You're not going to mock the behavior of the token itself. You'll call the functions of the smart contract of ERC20 token inside your deposit tests, and it's going to fail. This is like a hint for you, because you first need to approve the lending contract to spend this amount of tokens for you, and then to call the deposits. So we cannot test this scenario here inside the unit test, because we are mocking all of this stuff, but we tested proper emitting events, requires, and everything with mocks. And now inside the functional test, you will test the whole flow, and you will have the error because you haven't called approve function on the ERC20 token itself. So this is like a hint for you. The third set of contracts will be end-to-end set of tests, will be end-to-end tests, and you'll basically need to create another folder like this, and then inside your hardhat config.ts folder, let me quickly close all of this stuff. You can basically inside the networks, you can create Hardhat network and then add forking, something like this. So Hardhat, and then you can have, sorry, here is comma, something like forking, and then inside the forking you will have block number. You can start from this to fork your mainnet in this block, and then you'll need to have URL, right? And URL will be probably your Alchemy key for mainnet, or your Infura heap for mainnet. But you need to be sure that the historical blocks are also executed in your plan. For Infura, for Alchemy, it works out of the box. And finally, for the property-based testing, just go to Hardhat starter kit repo and go inside the contracts, and you'll find inside the test, you'll find fuzzing folder, and this is the echidna test for property-based testing for fuzzing. This is a config file for fuzzing, and then you'll have a simple command inside the package.json file to run these fuzz tests, and this is it. It's going to use this eth-security-toolbox image, Docker image, so make sure to wait for the first time, to this image to be downloaded, but after that it will work out of the box. So that's everything for this workshop. Make sure to scan this QR code and write your comments, thoughts, questions, whatever, because your feedback is really valuable to make these workshops even better. So what did you like today? What didn't you like? Do you want maybe something more to be added to this workshop? Because today we only covered like writing a unit test, and we just spoke about integrational tests and end-to-end test and functional test and property-based test and everything, because it takes time. We will have like security audit workshops at session later during this hackathon, so make sure to visit them as well, where we are going to talk a bit more about more advanced testing techniques. We are going to cover some common vulnerabilities, exploits, whatever. But yeah, make sure to scan this QR code to fill a simple type form. It's only 15 seconds, 45 seconds max, to give us feedback. Your feedback is very valuable, because at the end we are making these workshops for you guys. So that's it. I'll now stop sharing my screen. We have 4 minutes left, so if you have maybe any questions, I will try to answer them. If not, have an amazing hackathon. You can also reach out to me on Twitter as well, Andre-dev, _dev, pardon. After this session, maybe you can write on my wall something, and then we can start discussing in a thread, whatever. And yeah, best of luck during this hackathon. I really hope you're going to build something amazing. I really hope that you learn something new today, and I'm really excited for you guys. So thank you. Thanks again for joining this session. I know it's a bit early for the people maybe in the States. For the European-based people, it's just in time around lunch. For Australia and Asia, this was a good session right before like the evening dinner or nap, whatever. Thanks again, and see you in the next workshops. It was my pleasure hosting this for you guys. Thank you.